Okay, a small child is able to provide a force of 200 newtons trying to stay on a merry-go-round. If you can't remember what a merry-go-round is, it's one of those spinning rides in a playground where it's kind of like a circle, and let's say they're hanging on at the outside here, and this thing is spinning around. So it's a uniform circular motion question. They can provide a force of 200 newtons to maintain their circular motion. We're saying that they are 2.4 meters from the center. It's a pretty big merry-go-round. And we want to know what frequency you'd have to rotate this whole thing at for this child to fall off and not be able to provide the actual force required. Oh, and we gave him a mass of 20 kilograms. Okay, so I'm gonna take my centripetal force, my mass, and my acceleration, and I'm gonna come up with what acceleration this child is able to provide for themselves. So I said that they could provide a 200 Newton force. They weigh 20 kilograms, so my acceleration is 10 meters per second squared. And I want to know what frequency is going to cause them to fall off. Here, again, in a previous video, I took the typical formula for circular motion and I adjusted it for frequency. So if you want to see that one, I suggest going back and looking at that original video. 4 pi squared r f squared. So really this is just a matter of plugging all of this in and seeing how this works out. So 10, actually I'll just do all this first. 4 times 3.14 squared times 2.4 is 94.6. 0.106, and then I square root both. I don't need to worry about that. Square root gets you a positive or a negative situation here because frequency is an absolute value, so it doesn't really have a meaningful negative, so I can ignore that idea. And if this ride spins at 3.25 hertz, then we can imagine that that is how fast it would be going to cause the child to fall off. Doing this, I'm kind of curious to see what the velocity associated with that would have been. So if I go and use this formula, I've said it was going at 10 meters per second squared. Velocity squared equal over 2.4. So 24 meters squared per second squared, that's meters. It's velocity squared. So I'm going to square root both of these guys, and the velocity here is 4.9 meters per second. So don't get fooled, that frequency doesn't look all that big, but this is a great big ride, so it's going around once every 3 seconds, and that's pretty darn fast when you consider the overall size of the ride. And as a result, this thing's going pretty fast when that poor child falls off.